Hello and welcome everybody to the North American Ag Roundtable. This is a demo and discussion with CowKühlerZ, and the topic is precision heat stress prevention. I'll introduce Nancy and Martin. They both have a long history of agriculture, especially in dairy cows and also in beef cows. And they make sure that you visit their exhibitor page as well. It's full of some good information on NorthAmericanAg.com/exhibitors. And Martin and Nancy have really missed live events, just like most of us in agribusiness. We're used to being able to be close to farmers, close to our customers, and that's just not happening this year. So that's why we've created this venue to try to engage and provide information at this time. One thing that we really miss is live barn tours and farm tours and product demos and live field demos, which we can't have right now. So we're very fortunate to have a barn tour, and it's a pre-recorded barn tour, but it will be narrated live by Nancy. So we can get going, and yeah, take it away, Nancy.
Hello, welcome everyone. I'm so glad to have this opportunity to get to hang out with y'all today. So we're just going to start by explaining a little bit about what CowKühlerZ is in case people don't know. So CowKühlerZ offers a precision formula that is a cooling solution that prevents heat stress in dairy cattle by maintaining core body temperature. And systems are available for all kinds of barns, and they're designed for the farmer that's driven by technology, automation, conservation of power and water, all while maximizing cow comfort. So how do we do that? Well, we use three components. We have the cool blue fan, we have the controllers, and we have cooler nozzles. So the cool blue fan is powered by a direct drive EC motor from Zilabeg. It's variable speed, and it has an internal VFD, variable frequency drive. And that's really great because it's internal. There's no risk of stray voltage. Stray voltage is a big issue on farms that are, and oftentimes an external frequency drive is the cause of that. And then the variable speed is adjusted by the controller based on the temperature and humidity index in the barn, the THI. So the controllers are fitted with the temperature humidity index reader, and it's monitoring the environment in your barn 24 hours a day, 7 days a week, and adjusting the variable speed and the ultrafine droplet to all of the time, adjusting itself accordingly, and that works to maintain the core body temperature of the cow, or CBT. So what the cooler nozzles do is they create an imitation sweat. So cows don't sweat like humans do. They sweat about 10% of what we do. So on a hot day, when we're working outside, we start to sweat, and whenever those sweat droplets evaporate off of us, that's what actually cools us and helps us regulate our core body temperature. So what we're doing is we're actually creating that for the cow. So we create an imitation sweat. The ultrafine droplet lands on the cow's coat, and as it evaporates off of her, it creates a chilling effect on that blood that's flowing right close to the surface of her skin. That cooled blood is then pumped around her body, and that's what's used to maintain her core body temperature. So those are the components of the CowKühlerZ system and how it works together. So what we're going to do is we're going to take you on a barn tour. So let's just launch that. So this is the W. Gillen. Ooh, where did it go? Sorry about that. Fun with live stuff. Just go back. Okay. This is the W. Gillen farm, and it's run and owned and operated by the Gillen family near Pakenham, Ontario. This freestall barn was built in 2003, and it was retrofitted with robots in 2014. The CowKühlerZ system was installed in late 2016, so this is their 4th summer with the system. Cow comfort is paramount on this farm, and the decision to invest in a CowKühlerZ system was based on the science behind the system. The Gillens knew that fans alone could not offer cooling, and that water needed to be added to the equation to offer that cooling effect. Core body temperature cooling is way more effective than trying to cool the ambient air, and the CowKühler system does that effectively and efficiently. The variable speed and the time to find mist controlled by the monitor that monitors the temperature and humidity give the Gillens the ability to control core body temperature 24 hours a day, 7 days a week. Richie Gillen says, it's a full circle with each benefit impacting and influencing the cows. During the warmer months, the cows' intake stays more consistent and the cows stay in their stalls comfortably. We have experienced less metabolic issues and lameness. This in turn has helped improve our reproduction because we are dealing with healthier cows with pronounced heats. Production stays consistent month in and month out. And this means we are filling our fall incentive days. Our days in milk are great, and that has a big impact on the bottom line. So the Gillen system consists of 25-inch cool blue fans. And it has a Rube controller that controls the fine mist, and it has a blue controller which controls the fan speed. As you can see, the cows are super comfortable in their stalls. They're chewing their cuds, they're relaxed, and they're enjoying their day. And this is what a typical day in the Gillen farm looks like, because we just filmed this video last Wednesday on just a random day. And these were the cows enjoying their time in their stall. So on this day, the cooler nozzles, there was water being injected into the system. The coolers were on for 1 minute and then the fans were running for 3 minutes. So a lot of people think that we're pushing water out all the time, 24 hours a day, but that's not what's happening. It's actually timed. So the nozzles are misting and then just the fan is drying and evaporating up the water that's there. So this is the fan itself with the cooler nozzles mounted at the fan. There's a junction box so we can easily isolate the power. There's an air shaper on that fan, which is creating a very focused airstream. And that air shaper is actually causing that air to spiral. And you'll actually see as the mist is coming through that airstream, you'll actually see it spiraling through the airstream. They're mounted directly above the stalls. I don't know if you can see, there's like a water line that's going through the support posts there. That's running the water and the power is being run along the ceiling. And then there's a drop nozzle every 30 feet, which I think you could just see it there. I think we're going to go and look at it now. Yeah. So this nozzle is mounted every 30 feet and it's injecting more droplets into the air because the fans are mounted every 60 feet. And at the end of the 60 feet, we're still achieving a 5 mile per hour wind effective air movement. But of course, the droplets are heavier than the air, so we need to inject more droplets at the halfway mark so that everybody is getting the imitation sweat and getting that cooling effect as from the water droplets landing on them. So you can see that the droplets were floating through the air, but the bedding is still dry. It's still dusty. The cows are not soaking wet. So all of the water that we're putting in to the system, all the water that the system is pushing out into the barn is evaporating. It's not accumulating. So this is a very unique selling feature to the CowKühler system. And that's one of the amazing things about it, how it all works together, like the way that it does. And the bedding stays dry, the cows stay healthy, the cows are cooled, and it all works really seamlessly. So we're gonna head on over and around here past the robots, and just above the robots there's a couple of cool blue fans mounted above the robot as well. So this is actually the start of the stall cooling. So this fan is mounted here, and then these fans feed underneath the next fans that are 60 feet up, and then there's another set 60 feet up from that. And then, like I said, every 30 feet in between, we have cooler nozzles. So we're going to come around to here and have a look back here at this area, which is actually the calving area and the close-up area. I just wanted to take a minute to show you this. The Gillens were telling me that there's a noticeable decrease in the number of retained placentas since cooling the cows with the cow coolers. In fact, all the metabolic issues have declined dramatically. There's less ketosis and less mastitis. Since they've been using the cow cooler system, that is something that they've really noticed over the past 4 years that has really improved in their herd. So we're going to come on over here now to the bedding pack area. We get asked a lot if bedding packs work. So this, I'm sure you're all very interested. The cooler nozzles are misting, and as you can see, the pack is staying nice and dry. The air movement from the fan is actually working really well to keep the pack dry, keep it healthy. When we got here to start videoing, all these cows were laying down, but of course, since we're like strange, scary people, a lot of them did jump up, but they were all laying down and enjoying their day. So we're going to cruise on over here. I just want to take a minute to show you the brains of the system. So these are the controllers. That's the temperature humidity controller right there. I wanted to make sure that you saw it. This is telling us that the fan is running at 94% power and it's 71 degrees Fahrenheit in the barn. So it's monitoring that all of the time and adjusting the system accordingly. So yeah, so the fans were running at 94% power. So that's the variable speed. And because it was 71 degrees, that was the speed that it needed to be run at. And then was also injecting the water, which was at 1 minute on for the water, 3 minutes off. So those controllers, like I said, really are the brains of the cow cooler system. And it's how everything works together that we're able to cool the cow's core body temperature and prevent the effects of heat stress. So this is the second half of the barn. And again, we can just see that the cows are laying really comfortably in their stalls. They're not wet, they're nice and dry, they're chewing their cuds, and they are just having an absolutely fantastic day. This one here, she's having a really good nap. She's like completely out of it. Having a good little sleep, which is exactly what we want. So a lot of times whenever I go and visit farms, farmers are telling me that their cows don't use that outside row. So I just wanted to show you that here at the Gillen farm, the cows are using that outside row. Richie and the Gillen family, they decided that they were going to try lowering those top curtains this year. So that's what they've been doing. They've been running that top curtain down, and then the bottom curtain is open. So what that's actually letting the system do is not compete with Mother Nature. And it's also providing a bit more shade for the cows. So they're actually having some really positive results from having that happen, from that experiment. So they're really quite happy with that. As you can see, again, the cows are laying nice and comfortably. I don't know if you noticed the water lines. I was supposed to mention them, but I got too chatty. But you can actually see the water line running along the edge of the curtain there. And then the electricity is actually coming down along the roof line. So there's, and then this is the nozzle that's at the 30-foot mark. That's going on right there as well. So that's kind of a little overview of how the install goes in as well. And then again, just to show you again that the is dry and the cows are really quite happy there. So that's great. And then the mist is, I just wanted to be able to show you that the coolers were injecting water into the system right now. And then we're going to show you on the cow's back that you can't actually see an accumulation of the droplets. So that water is going out there. It's going into the air. The droplets are so fine. They're landing on the cow's coat, they're evaporating, and they're creating that chilling effect that I was talking to you about. And the result of that is nice, comfy, cool cows chewing their cuds and performing to the maximum they can to the maximum, which is what we want, and so that's really great. Just checking my notes to make sure I don't forget to tell you something. Okay. So the last thing that I wanted to mention was one more thing that the Gillen family told me. So they said, it's not just about the 15 hot days in summer. We get benefits from the system almost all year round because of the variable speed. The controllers monitor the conditions in the barn and adjust the system to keep the cows in their thermal comfort zone, and it all happens automatically. There are a lot of days in the spring and the summer that the fans are running as well. Sorry, the spring and the fall and the winter that the fans are running as well. So the other really interesting thing that the Gillens have noticed is that they have a lot less lameness issues. The cows' hoof health is exponentially better. They were saying that they used to have to block cows all of the time, and now the hoof trimming rack basically sits over there and gathers dust. So for them, that was a really big difference that they saw in their herd with putting the cow cooler system in. And a big reason for that is because you're getting cooling with minimal amounts of water. So often when you're not cooling at all, the cows are standing for a whole bunch of extra hours a day, and that's putting a lot more pressure on them. And so you're having more instances of hoof health. And so they're in their stalls resting and laying down. And then the other thing is with bunk line soakers, what you'll find is that the cows are standing at the bunk. They're not actively eating. They're actually standing there so that they can be cooled by the soakers. And so there's twofold there. They're standing longer, and also they're standing in a whole lot of water. And just standing in all of that wet is not good for their hoof health either. So that drives up the instances of hoof issues as well. So so really, that's a really great benefit of the cow cooler system using minimal amounts of water. The other great thing about the minimal amounts of water, it uses about a quarter of what a bunk line system would use. So that creates a lot less management issues because all of that water that you're injecting into your system using a bunk line soaker has to go somewhere, and it ends up in your manure pit storage. And then it becomes a management issue because you've got to get it all out, you know. So the great thing about the cow cooler system is that all of the water that it's putting into the system is being evaporated and being used up. So that's another great thing. Pretty much all of these points we talked about while the video was running. So we're good to continue on. So a lot of people want to know what areas we can cool. So this is a holding area. This one is actually in Wisconsin. And it's arguably the most important place to cool on your farm. Temperatures can spike to like 105 degrees often in the summertime whenever the cows are packed in. In fact, if you had 100 cows in your holding area, they're generating 150 watts or BTUs, which is basically the same as cramming 100 space heaters in that area. So what happens is those temperatures spike, and then when they're up there, when your cow's temperature is 105 degrees, that can have catastrophic effects on your embryos, and you can actually cause pregnancies to terminate before you even know those cows are pregnant. So so that has a huge impact on summer reproduction. I just wanted to show you this. So I just shot this video just quickly in Wisconsin while I was there. And you can see that we have 4 rows of fans in the second row, and then we have 4 rows of fans in the front row. The cooler nozzles are on, and so the cooler nozzles are throwing water out all of the time. You can tell that the fans are at a much more severe angle in the holding area, and they're much closer together. And that's so we're blasting that air all in, down, around her flank, around her body, and we're really pushing that air and that cooling effect in between those cows that are so closely together. So we're having with very effective cooling your holding area. Technical glitch. There we go. So at the Gillens, we saw freestyle cooling. I just wanted to just take a minute to run through that so that you knew that we were doing that as well. And I have another short video of a cow very comfortably chewing her cud and having a great day. This one is on sand bedding as opposed to at Gillens where we were on water beds with sawdust, DCC water beds with sawdust. So it's just nice to see that the bedding type can vary as well. So dry cow cooling is another really huge place where we can have a really massive impact. So at the Gillens, they were saying that since they've been cooling their dry cows, they noticed that their calves are born heavier, they hit the ground running, they're healthier, they are growing faster, and they're outperforming their sisters from the years before that hadn't been cooled. So that makes me really happy to hear that customers are having that result and that they're seeing those. And there's a lot of research as well that proves that cooling dry cows is very, very important, and that there's a lot of benefits to cooling dry cows. So this is actually a really short video that a customer from New York, near Seneca Falls in New York, he put this system in last year. He's only done half of the barn. So this half of the barn that we're looking at has a cow cooler system in it. The other side of the barn that's on the far side of the video does not. So he sent me this video in an email, and he said that the cows were just really great, that there was a lot less perching, and that the cows were doing so much better, and that he could see the difference between the side that wasn't cooled and the side that was cooled, and that the side with the cow coolers was doing really, really great. So I just wanted to share that video with you because it's always great whenever customers send us information on how their cows are doing. We also cool tie stalls. In fact, we have a real advantage in tie stalls in the fact that our fan is 25 inches. So it really fits in well in low ceilings, and also that spiraling airflow, like all of those posts, the pipelines, the obstructions, that spiraling airflow really deals well with that tie stall situation. And the farmers that we install for in tie stall barns, they are always really, really happy with the results that they experience. I have this video from, so this tie stall farmer sent me this video last summer. They have 2 fans that they've actually mounted in that rock wall that you saw at the far end, and every single cow in the barn is laying down. They have a cooler nozzle, and so he is really, really happy because he had absolutely no drop in production. He said that prior to putting the cow cooler system in, they'd always have massive drops in the summer because the cows got really, really hot. And so no drop in production, which they were super happy with. And also reproduction. He said he never used to breed a cow. The whole month of July, August, and September, he never breed a cow. And now he's actually, able to breed those cows on their first breeding cycle, get them back into calf, and hit all of his fall incentive days, and, keep everything going on schedule, which has had a huge impact on his operation. So he's super happy with that result. And then bedding pack. Oh my goodness, I can't tell you how many times people have said, well, you cannot put your system over a bedding pack. But like you saw in the Gillen video, you know, that pack was nice and dry. It's really healthy. We actually even have a bedding pack farmer who said that in the winter, the fans come on at 30% and dry the pack and change the air, and that they're having really great success with cow coolers over their bedding pack. So and then so I have this little video here to show you. And again, we just shot this one day. So the fans are mounted on the feed bunk, and then you saw the cooler nozzle. So they're actually shooting this way across the pack rather than like up and down the pack. And then the fan is, so that's the feed alley right there is what I was trying to show you. So pack cooling, and then bunk line cooling. So I went to see this farmer. He's near Erie, Pennsylvania, and he had these the bunk system set up. And I hadn't really been to a whole lot of farms that had a bunk system. So I said to him, you know, why are you cooling the bunk, and what are the benefits of cooling the bunk? So he's like super great farmer, and he says to me, well, whenever we're cooling the bunk, we're reducing the amount of slug feeding. And I was like, I don't even know what slug feeding is. So it was a big day of education for me. So he was saying that when the cows wait until the ambient air temperature cools down to eat, they go to the bunk whenever it's cool, and they eat, and they get really full. And then they go back and they lay down, and then they're trying to digest this large quantity of starch and sugar, and it's like wreaking havoc with their pH, and the cows can develop ruminal acidosis, and there's a whole bunch of negative impacts on rumen health. And whenever that happens, that affects milk production and the components. So for him, bunk cooling was a no-brainer because it keeps his components up and it keeps his milk production up. So now I'm a big fan of bunk cooling. And I also went and saw this farm here, and there's a video of the bunk cooler going. So I didn't know that I was going to be doing this at the time, or I would have taken a better video. I'm really, really sorry. But so the airflow, the spiraling airflow is going down that line of cows, hitting them on their core body. The coolers are putting mist into the air, and so they're comfortably cool while they're eating and while they're in their stalls. So, all right. So a lot of times we get told, you know, why should we invest in a cow cooler system? So this slide here is all about how cow coolers is more than just a fan. And these are some of my favorite value added features. So we touched briefly on the internal VFD. So that's the internal variable frequency drive, which means that there's no chance of stray voltage. So a lot of times guys are going to sell you just a fan, and they're going to try and fit it with an external variable frequency drive. Well, that can create stray voltage, and stray voltage is decimating on dairy farms, on any farm. The variable speed, that is another huge feature. When you have just a fan, you have to make that decision when you're going to flip the switch and have it running at 100% power. The variable speed allows you to have that flexibility to run the fan earlier and have that air cooling earlier and keep that core body temperature where you want it to be, which is in her thermal comfort zone. It's all powered by the Zielebeg motor, which is a direct drive EC motor. And the cool thing is that an EC motor so regular fan is an AC motor, and an EC motor is like an LED light bulb. So this is the difference between an LED light bulb and a 60-watt light bulb. There's that much difference in the efficiency and the way that this motor runs. It's a low pressure misting system, which is really different. A lot of systems out there use a high pressure system. This is a low pressure system. It basically just runs off of tap pressure. The fan speed, variable speed, it's controlled by the THI, the temperature humidity in the barn. And so as the temperature rises, the speed increases. And that way we know that we're getting exactly the right amount of cooling all the time. The system is really low maintenance. So that's because it's a direct drive, there's no belts to maintain. And we also have a spring and fall maintenance schedule that clarifies what the maintenance is that's needed, but there's really very little. So it has the added benefit of evaporated cooling. And that is the added sweat that's controlled again by the temperature humidity index. So on a really hot day, we are injecting less, on a really humid day, we're injecting less water into the system. And so that all happens seamlessly. Zero manpower is needed. You don't have to worry about somebody having to run back to the barn to flick a switch to turn the fans on, or to flick a switch to turn the fans off, or whatever. That's all happening seamlessly as you go. The whole system is fully automated. It continuously monitors. So this is another really great value-added benefit, is that it draws 3 amps of power versus 5 to 6 amps of power. So that just a fan is consuming a whole lot more amps of power. It has 0 to 1200 RPM. We do maximum cooling using minimal amounts of water. The bedding stays dry. The spiraling focused airstream, we already talked about that. There's an effective air movement of 5 miles per hour at 60 feet. The system is, the fans are very quiet. Even at 100% power, they're quieter than just a fan. It has a very short-term, fast return on investment. Many farmers see benefits 365 days a year, and we are preventing heat stress before it starts. So those are some of my favorite value-added benefits that CowKühlerZ offers. What's my next slide? Oh yeah, okay. So we developed this handy dandy cost calculator. I've linked up the US cost calculator for today, but we also have a Canadian one. So we can put in the number of cows, and then we can alter pretty much most of these ones that are in orange here to reflect whoever's operation that we want them to reflect. So in this instance here, we have the cost of subclinical and clinical mastitis, hoof health, replacements because of heat stress, pregnancy rate, reproduction, milk price, and drop in production. So for the pregnancy rate, we did a drop in production of 25%. And for milk prices, we did 18 cents per hundredweight, and with an average milk production of 70 pounds per cow, and then a 10% drop in production. Now that 10% drop in production is being really conservative. The research is showing that that farmers are experiencing anywhere from 10 to 35% loss of production. So there's a lot of flexibility in there, but we chose to put it at 10%. So that comes out to $145,000 a year, which actually works out to $296 per cow per year. So heat stress can cost operations a lot of money, and it's really good to be able to see what that is in black and white numbers, so that we can so we know what preventing heat stress could actually mean for us. Did you have anything to add there, Martin?
That's all fine. Thank
That's
you.
all fine. Okay. So the next one is the energy usage calculator. So this one is really interesting. So those 500 cows, if we're going to buy them a CowKühler system, we would need 33 units to cool that number of cows. And the total cost of the system is $101,000. If we were going to have the same effective air movement, we would need to buy 75 traditional fans. So that's so that every single stall has 5 miles per hour effective air movement or better. So they would need 75. And that system costs $105,000. So we're looking at a very similar costings there for the systems. But where it really starts coming ahead is in the electrical usage. So the CowKühler system is going to use about $3,500 of power a year, whereas this traditional fan system, it is actually, oh, Nancy Margaret, sorry about that, everyone, is going to use $19,000 worth of power a year. So that's, again, because of the EC motor. The EC motor versus an AC motor, the magnetic drive, the direct drive, that all of those things work together to create a really efficient system. Did you have anything to add to this one, Martin?
Oh,
I didn't do such a good job of that slide earlier, so that's why I'm checking with Martin to make sure I've got everything right. All right, so an easy way for you to check heat stress in your dairy herd is to monitor your milk temperature. So milk temperature is basically the same temperature as blood, and blood is the same temperature as your cow's core body temperature. So as she gets heat stressed, you're going to see that that temperature is going to rise and rise. This was a huge eureka moment for me. I'd gone to see a farmer in Quebec, and he said to me, before we put the CowKühler system in, the alarms would be going off all summer long on my milk machines. And now, since we put the CowKühler system in, this is our third summer, and those alarms don't go off at all anymore. So we know that the cows are comfortable and cool, because that milk temperature is always consistent, and they're always in their thermal comfort zone. It's always a good temperature, and the cows are happy. I mean, there's a bunch of other stuff that happens as well, like his production stays high and his reproduction and everything. But he was the one who really made me hear that milk temperature and core body temperature are linked, right? So on this system here, this is the only one that's kind of clear enough to read. The temperature is 102.5 degrees Fahrenheit. So this is a really great way. And then this is just a THI chart. And I just put this one up here because it had Fahrenheit and Celsius, and you know, it was pretty easy to read. But if you want to have a look at a THI chart, you can just Google that on Google, and there's literally hundreds on the internet. So I touched briefly on this before. So if you need more cooling, if heat stress is an issue for you, but you're running out of amps, CowKühlers can be a really great fit for you. So I went to see this farmer, and I said to him, why did you choose CowKühlers, right? That's always the question. Why did you take this jump? Why did you decide to invest in CowKühlers? And he says to me, well, for me, it was the fact that you only draw 3 amps of power. And I said, like, what do you mean? I don't understand. So this is what he said to me, what's written here. He said, we took out 48 52-inch panel fans that were using 5 amps of power, which totaled 240 amps. We replaced them with 36 cool blue fans that use 3 amps of power, totaling 108 amps. That's a reduction in consumption of 132 amps. That's a massive savings, and it freed up all of those amps for him to use elsewhere on the farm. Not to mention the fact that the air quality is better, the cows are healthier, and they had the added benefit of water cooling. It was all win-win. So for me, that was a big thing, right? So I've only been with CowKühlers for just over a year. So I've been on this huge educational journey as well. So whenever I talk to you about eureka moments and things that make me go, it actually really, really happened. I'm discovering this, I'm discovering new benefits every day. And you know, my very favorite thing is to go and talk to customers and learn from customers, because they just have the greatest way of explaining stuff to me and helping me to learn and to understand. So I wanted to share that with you today. And then we talk about putting the water over the beds, mounting the fans, mounting the cool blue fans over the stalls, and you know, putting water over the beds, because we get asked that question a lot, and people just find it really hard to believe that the beds don't get wet. So this customer here was telling me that the bedding stays dry, their somatic cell count is below 100,000. They're really happy with that somatic cell count, and having the water over the beds has not caused that somatic cell count to rise. The droplets are really small and they evaporate, and as long as the stalls aren't empty for long periods of time, the bedding stays dry. And that the cow cooler system takes the workload off of maintaining comfort in the barn. So they're really appreciative of the fact that they can, you know, be in the field or go to town or go see the kids' soccer games, and they know that the cow cooler system is working hard to maintain their cow's core body temperature and maximize their production. An interesting point in this testimonial is as long as the stalls aren't empty for long periods of time. So that's all about stocking rate and stuff like that. So if you have 20 empty stalls, then, you know, things could happen. But as long as you've got a good stocking rate and everything is good, your stalls are not going to get wet and the system is going to work perfectly. So these are just some cool results, some other cool results that we can look at, but I just wanted to check in with Chrissy first and see if there were any questions. Oh, I can't hear you. You're on mute. You're on mute. Oh, there she is.
Rookie mistake. That was awesome presentation. I love that data. Nancy knows me and knows that I love numbers. So being able to flow through that and see with the savings, it really does seem like a no-brainer. Excellent presentation. That was awesome. And what I always find is so amazing, the lengths that farmers go to for cow comfort. It really is astounding, and you know, we can be really proud of this industry, and that, you know, that comfort is the number one thing, right? So we do have a few questions. What happens with the water lines in the winter?
So that's part of the fall maintenance schedule. So then the water lines are blown out and kept empty. There is a solenoid valve filtration system that actually can get disconnected and brought into the barn so that it doesn't freeze. Alternatively, it can get mounted in the milk house where it won't freeze. So all of the lines are empty for the winter.
Okay. Here's another question. Is the first video available online?
It is on our CowKühlerZ YouTube channel.
Awesome. Very good. Another question. The company is from Germany. When did it start offering the product in Canada and North America? I guess that's a Martin question or a you question.
So in Canada 4 years ago, and in the US it started a lot earlier. So we are about 7 years on the market in the US.
Awesome. What other countries are you available in as well?
The other countries are in Europe, so Germany, of course, Portugal, Cyprus, Slovenia. Yeah, these are the ones.
And do you cool just cows, or are there other animals that can benefit from this?
So the system can be used to cool other animals as well. We do have in the US one sow unit that is using the system. Theoretically, it could be used to cool milk goats, sheep, but it's a question of the standard of the farm and the milk price that they can get.
Awesome. Another question, how much water does the system use?
So it uses, at maximum operation, which is 1 minute on, 1 minute off, it uses 1.7 liters per cow per hour, which is the equivalent of 1/4 of a gallon per cow per hour. And that's at maximum operation, which is 1 minute on, 1 minute off.
Wow, that's reasonable. How much line pressure do I need for the nozzles?
I'm going to let Martin answer that one.
Okay. So the nozzles will work in a range between 25 psi up to 60 psi. So there's no additional booster pump needed. It can work right off the mains line pressure.
All right, awesome. And what about water quality? What quality do I need?
You should use potable water. So that means it should be clean water and it should be soft to reduce the possibility of calcium buildup around the end of the nozzle. So yeah, the best would be to use the water, the soft water from the parlor.
Great. All right. And what power do I need? Single phase or three phase?
Both. Or you can, so you need to decide or you need to know what power system is existing in the barn. But we do have motors which can be used for single phase and we have three phase versions as well.
Awesome. Very good. Yeah, so that's it for the questions. Anything else you want to add?
So I have one last quote from the Gillens. A lot of times people say to us, you know, oh, that's a lot of money for 10 hot days in July. So what the Gillens have to say about that is it's not just about those 15 days in the summer. We get benefits from the system almost year round because of the variable speed. The controllers are monitoring the conditions in the barn and adjust the system to keep their cows in their thermal comfort zone at all times, and this happens automatically. There are a lot of days in the spring and the fall that the fans are running as well. So for them, there's benefits almost all year round from having the cow cooler system on. And it's the same in tie stall operations. I had a tie stall guy call me in December and he said, Nancy, the fans are coming on at 30%. They're drying out all of the moisture, they're changing the air, and we're milking and we don't even notice that they're running. All of this is just happening because the system is so automated and so well put together. So that's definitely something that I would want people to keep in mind, that we're not just cooling cows for those few hot days in the summer, that there are a lot of benefits all year round to using a variable speed fan that's controlled by the temperature humidity index.
Awesome. Very good.
How about you, Martin?
Sorry?
Do you have anything to add?
No, I'm fine. Or I think we gave pretty good information about the system. Yes.
All right. Awesome.
Yeah, and just for everyone to know, you can visit northamericanag.com/exhibitors, to find CowKühlerZ there. You can also go to CowKühlerZ.com, and you can reach Nancy also on Twitter and Facebook and LinkedIn, Instagram too, I think. Yep. So she's pretty much everywhere, and she is ready to take your questions. So yeah, so that's it. Thank you all for joining us, and yeah, and thank you, Nancy and Martin. What a great presentation.
Thank you for having us, Chrissy. We really appreciated the opportunity to be part of North American Ag Roundtable. It was really great to be involved and to be invited. So thank you very much for having us.
Awesome. Thanks so much.
All right.
Thank you.
Bye.
Bye.